All right, let's just get one thing straight. That grid of cells you look at every day, I want you to forget everything you think you know about it. Because today we are going to unlock its hidden power. We're going to transform it from just, a simple spreadsheet into this powerful workbench where you can actually build your ideas.
So, let me start with this question. What if this thing wasn't a spreadsheet? I mean, seriously, try to erase that mental image of boring tables and data entry. What if it was something more? Because guess what? It is more. I want you to start thinking of Excel as your own personal workbench. It's this dynamic space where you can craft, you can test, and you can build really sophisticated models. This is the place where you shape raw data into powerful, meaningful insights.
Okay, so to really command this workbench, you've got to learn its language. And just like any language, it has a grammar, a set of rules that dictates exactly how it works. And trust me, this is the foundation for everything we're going to build today.
So this right here, this is the grammar of Excel. Let's call it a mechanical processor. It doesn't just read from left to right like we do, no. It follows a super strict order of operations. First, it handles negation, then percents, then exponents, and so on. But I want you to pay really close attention to that fourth step, multiplication and division. This is where so many people get tripped up.
Let's look at a classic example, right? You've got division and multiplication, which, as we just saw, have the exact same priority. So what does the workbench do first? I mean, does it multiply 10 by 2 and then divide? Or is there something else going on here?
And here is the all-important tiebreaker. It's called the left-to-right tie rule. When operations have the same priority, like our multiplication and division example, Excel just works from left to right. That means it's going to handle the division first, simply because it shows up first in the formula.
Which means the answer is 20. So first, the workbench calculates 100 divided by 10, which gives us 10. Then, and only then, it multiplies that result by 2. Just mastering this one simple rule is going to prevent countless common errors down the road.
All right, now that we can speak the language, it's time to learn how to navigate the grid. We're about to dive into cell referencing, and let me tell you, this is one of the most powerful concepts in all of Excel.
And the absolute best way to understand this is with an analogy. Think of a relative reference. It's like giving someone turn-by-turn GPS directions. Go 1 block east and 2 blocks south, right? If you copy that formula, the directions just adjust from your new starting point. But an absolute reference, that's totally different. That's like a fixed street address. Go to 123 Main Street. It doesn't matter where you are, it always points back to that one specific spot.
So, here's how this actually looks on the workbench. A simple C5. No frills. That's relative. But see those dollar signs? Those are the magic symbols here. A dollar sign before the column letter, the C, locks the column. A dollar sign before the row number, the 5, locks the row. And $2 signs, well, that's your fixed street address.
And this is such a crucial concept, so I really want this to sink in. In absolute reference, your $C5 acts like a steel anchor on your grid. When you copy and drag that formula, that part of it stays locked, completely fixed on a cell C5. It never, ever moves. This right here is the key to building models that are both scalable and efficient. Okay, we've covered the grammar, we've covered navigation. Now let's introduce a tool that does a lot of the heavy lifting for you. It's kind of like having a smart assistant built right into your workbench.
You know that tiny little square in the bottom right corner of a cell you've selected? That's the autofill handle. But it is so much more than just a button. I want you to think of it as a robotic arm that understands patterns and is designed to save you an incredible amount of time.
I mean, look at this in action. Give it a simple series like 1 and 2, and bam, it knows you want to keep counting. Give it a couple of months, Jan, Feb, and it'll fill in the rest of the year for you. It really does seem like magic, doesn't it? So, how does it do that? Is this just some clever party trick? Is the workbench literally just guessing what you want to do next?
Well, the answer is actually way more interesting than that. See, it's not magic at all, it's math. The autofill function uses a really cool principle called the least squared method. It takes the data points you give it, it mathematically fits a straight line to them, and then it uses that line to intelligently predict the next values in the series. It's a super smart prediction, not a guess.
So, let's recap. We've learned the grammar, we've learned the navigation, and we now know how to use our smart assistant. By really mastering these fundamentals, you're making a huge leap. You're going from a simple apprentice to a true architect on this workbench.
And that brings us to maybe the most important takeaway of all. The order of operations, that $ anchor, the autofill handle. These aren't just features you click on. They are the logic gates. They are the fundamental building blocks you're going to use to build powerful, scalable, and honestly, elegant models that solve real business problems.
By understanding these core principles, you've moved way beyond just plugging data into cells. You've actually learned the language of the workbench. And now that you've mastered the grammar, you're finally ready to write the story of your data.